welcome to my problem solving channel. So this one is also, we're just doing this JEE 2025 paper 2. Okay, so this, we're all the way to question 12. Today I'm doing a whole bunch of them. I'm in a roll. Wow. Okay, so this problem is about geocentric orbit. So here is Earth. So this is the center of the Earth. So there is one orbit at R1. So it's this. And then in the opposite direction to the Earth rotation, it's R2 from the center. And then you have another less you can put any place, which is R1 is 1.21 times R2. So another one is over here, and it's going its orbit like that. Maybe this guy is going this way, so the second one is going that way. So you can see there's a whole bunch of different frames here, right? You have a frame let's see, this guy put one here, put two here. So there is this frame which is fixed. So this guy is going in the opposite. So this is the second one is an equatorial plane. So I'm just looking from the above. So they look this way to me. And this one is geocentric, means its time period is equal to 24 hours, and is angular. If you look at the angle covered, angular rate will be 2 pi over T1. This guy, let's call this guy, this guy's time period, I'm going to call it T2, and angular frequency, or ang. So omega 2 equals to 2 pi by T2. So now imagine that we're going to rotate ourselves with this guy. Then this guy's angular velocity will be, so I'm in this frame, so frame F1, then in frame F1, this guy will be rotating at angular speeds of this guy with respect to the original one plus this guy with respect to the original one, right? So the way I'm going to see the time period of this from here, time period of 2 with respect to 1, let's call it T, this could be 1 over or 2 pi over omega 1 plus omega 2. Omega 1 plus omega 2. Because now this will be the angular velocity I should see. It's kind of like the rotation for the rotating frame. What you would be thinking, like I have this guy with a velocity v1 and this guy with velocity v2 with respect to both of them with respect to O. Then what's the velocity of v2 with respect to 1? Well, velocity of 2 with respect to 1 will be, is going in that direction negative. So this is going to be minus v2, this guy with that guy. So this is actually a minus v2 minus v1. This is the positive with respect to O. So it's they add up. So this guy will be going like, as far as this guy is concerned, this guy will be going that much velocity. Same way here. So velocity is adding up. Angular velocity is adding up here. And so we need to figure out in this problem 2 pi, this is 2 pi over t1 plus 2 pi over t2. And clearly if so this is supposed to be in here. Let's say so t equals to, if you simplify it, these 2 pi's will cancel out. 1 over t1 plus 1 over t2. So it's going to be t1 t2 over t1 plus t2. And this whole thing, inverse of that is p. So we're supposed to write t1 t2 over t1 plus t2. We're supposed to write t1 over t1 plus t2 over t2, and this is equal to p. So t1 is already 24 hours, so we need to figure out ratio of t1 to t2 and add 1 to it. Okay, so how do I figure out t2? T2 is the period of this guy with respect to the original frame. Okay, it says just have to probably write down equation of motion. So to find T2, let's work that out. Equation of motion. Is in a circular orbit, so mv square over r2 equals to gm over r2 square. Let's call this v2, and v2 will be 2 pi r2 over t2. So now plug in there. Let's see how far we go. We go, m's cancel out. So this guy cancels this guy out. Square is so I get rid of this. you get a square root of this, then invert it. So T2 over 2 pi R2 is square root of R2 over GM, and send this on the other side. T2 is 2 pi okay, so now we don't know these values, we just know R2, R1, R2. We know R1 over R2 is 1 over 2, and 1 over 2, 1. So most we can do is get ratio somehow. So over here, when you look at it, when you look at P will be T1 over T2 plus 1. So as long as we get a ratio, we'll be fine, okay? So maybe this means set up equation of motion of 1 also. So if I go through this, it will be exactly the same, and I'll come down here, and the only difference will be T1 will be 2 pi R1 is square root R1 over square root of GM. So now for P will be 1 plus T1 over T2, and you can see all of these guys got cancel out. So 1 plus R1 over R2 is square root of R1 over R2. It's like that. So 1 plus 1.21 square root of 1.21. I think it's 11 times 11 is 121. So 1.1 times 1.1 will be 1.21. So this is 1 plus 1.21 times 1.1. And we just have to work, do the calculator, and 1 to 1, 1 to 1. So, and the decimal will be three decimal places. So this will be 2.331. And I think they just want this as an answer. Something like that. One of these answer. 2 or 3 decimal places. So that will be the answer. So let's write down 2.33 as an answer. 2.33. So P equals 2. The value of P equals 2.331. All right. And this was a little roundabout way to do it. The main insight is that when I see from this a frame attached to this will rotate. So we imagine a frame that's rotating with this guy. This will see this rotating at some of the angular velocities. These are omega 1 and omega 2 are the angular velocities. Velocities of 1 and 2 with respect to not this frame, but with the fixed frame. So this is the insight, and everything after that is kind of we're trying to figure out where we're going to get T1 over T2. So we're trying to get T2, and we see we don't know a whole bunch of stuff. We don't know these this whole thing. We just know the ratio. So we realize that P only depends on the ratio, and the T's will have exactly same calculation for T1. I don't need to repeat it. That's why I put the indices here. So, you know, there should have been index here too, but they cancel out, so it didn't matter. So I could write this just from inspection, and the calculation goes pretty quickly. So I think this can be done within 3 minutes if you once you get an idea. Once you get this idea, then you can just go ahead and really bulldoze it. Pretty straightforward. Okay. I'll see you in another problem. Take care. Bye.